Hey guys, welcome back to Kolbenkraft. When a commercial vehicle is designed, the passenger comfort is a very important factor to consider. And here, when we talk about passenger comfort, obviously we are going to take into consideration the suspension system. So, for a good passenger comfort, one might say that why not just use soft springs? In that way, the road shocks will be easily absorbed, right? Well, actually, no. When we are talking about passenger comfort, we need to take into consideration the frequency of the wheel. Now, frequency, as we all know, is basically cycles per second. So, what cycles are we talking here about? When a wheel encounters a road bump, there is an amplitude. Let us draw an amplitude versus time graph of this to understand this better. When the road shock is absorbed, the amplitude rises and after some times it becomes stable. This is called one cycle and the number of such cycles is called a frequency. Number of such cycles per second is called a frequency. And for commercial vehicles, this frequency ranges from 1 to 1.22 Hz. With the help of this given frequency, or we can say assumed frequency, and the measured axle load, one can determine the spring rate. And for this, we will be taking into the consideration this formula over here. Here, M is the axle load and C is the desired spring rate. So for a given amount of frequency and axle load, we can achieve the spring rate. But this is not the thing where it ends. The frequency of the rear wheels has to be greater than the front wheels. The reason behind this is that the rear wheels will face the road shocks after the front wheels, and as a result, there remains very less time for them to be steady. Note that front and the rear wheels need to reach the stability at the same time to avoid any unwanted bouncing. When all the wheels are steady at the same time, it will provide better passenger comfort. So all in all, frequency of rear wheels should be greater than frequency of the front wheels. But wait a minute, if the frequency of the rear wheels is higher, that means the suspension system of the rear wheels have higher spring rate, which means that the suspension in the rear wheels are much more stiffer than the front wheels. So this can lead to oversteer. But as we all know, the world of automobile is just like relationships, is all about compromise. So we need to select such a spring rate, such a frequency, so that it provides a better passenger comfort and also does not lead to an oversteer. But the thing doesn't end over here yet. When we talked about the frequency, we saw that it is directly dependent on the spring rate. But the spring rate we are talking about here is the effective spring rate which is available at the wheels. This is much different than the spring rate available in the suspension system itself, that is the spring rate of the springs. So these two terms are very different, and how do they differ from each other? We'll see that in the next video.